Το πρόγραμμα είναι κατάλληλο για άνω των 8 ετών.
Welcome to the Cosmic Front. Today we profile two space monsters. The Japanese scientists who discovered these gigantic configurations in space have named them Hίμiko and Oroτσι. They believe that these monsters hold the secrets of galactic evolution. We're off on a new space adventure. Prehistoric Earth was ruled by giant dinosaurs. Humans have known of their existence only since the second half of the 17th century. No one had imagined that such monsters actually existed. Today, similar shocks are arising in space. The received astronomical wisdom is being overturned by the discovery of one monster after another. The largest objects in space are galaxies. The Milky Way galaxy, in which our own Earth is located, is comprised of more than 100 billion stars. But there are mega-galaxies out there, with upwards of 10 times the mass of the Milky Way. Their size is so mind-boggling, they are called monster galaxies. Chile's Atacama Desert is a plateau 5,000 meters above sea level. A telescopic array called ALMA has been in full-scale operation here since 2013. ALMA's 66 radio antennas let it make detailed observations of celestial bodies more than 10 billion light-years from Earth. 10 kilometers or so from ALMA, the ASTE telescope was built by Japan in conjunction with testing for the ALMA project. It was in 2008 that a major discovery originating here astonished the world. Data gathered at ASTE was sent to Japan's National Astronomical Observatory in Tokyo, some 17,000 kilometers away. So Ikarashi was a member of the observation team. At that time, he was a senior at the University of Tokyo. They were focusing on an area in the constellation Cetus, or Whale, known as the Subaru XMM Newton Deep Field. Images taken by the Subaru telescope in Hawaii had revealed galaxies billions of light years away. In space, the farther away an object is, the older its visible form. So we are seeing galaxies as they looked billions of years ago. ASTE would observe the center of that deep field sector in a search for galaxies 10 billion light years away. The Subaru telescope, like the Hubble Space Telescope, registers mostly frequencies in the visible light spectrum, not very different from what the human eye can observe. But the ALMA and ASTE telescopes can detect wavelengths in the sub-millimeter range. Thanks to good weather, the 2008 observation, budgeted for 200 hours, was completed in 150 hours. In the remaining 50 hours, they expanded the search to the area in this circle. The search in this additional area was entrusted to the young Ikarashi, and he spotted a phenomenon no one had ever seen before.
通常ですね、遠くの銀河というものはですね、何十時間も観測してやっと、見えてくるようなものなのですが、わずか1時間2時間のデータを足し合わせただけでもうすでに何か映っている。
This is what he saw. After just 90 minutes of observation, an object appeared that was emitting intense radio waves. The small red dots are normal galaxies. The large red blob indicates an incredible amount of radiation. When Ikarashi's superior at the University of Tokyo, Kotaro Kono, saw that image, he couldn't believe his eyes.
従来知られていたような割と距離の近いところにある天体を見てんじゃないかと、たまたまそれが見つかったんじゃないかというようなことを思いましたね。
Such intense radiation would indicate enormous mass. Weren't they misinterpreting it somehow? Repeated recalculations, however, proved that there was no observational error. There was indeed a mysterious giant in deep space, one never before seen. In 2011, Ikarashi conducted a further observation of this mystery object, using other radio telescopes atop Mauna Kea, Hawaii. This observation confirmed the precise location and shape of the object. It was calculated to be an amazing 11.8 billion light-years from Earth, a galaxy that existed 11.8 billion years ago. Furthermore, calculations based on the object's brightness showed it to have contained 100 times as many stars as our own Milky Way galaxy. That made it a supergiant, a mega-galaxy unlike anything else visible in the universe today. Ikarashi named this astounding galaxy after a many-headed Japanese monster, Oroτσι. When Ikarashi checked these findings against the image from the Subaru telescope, he discovered something remarkable. The Oroτσι megagalaxy was not where the radio telescope said it should be. Ikarashi speculated that a thick cloud of gas and dust enveloping Oroτσι rendered it undetectable by a visible light spectrum telescope like Subaru.
星の材料になる塵やガスにですね、包まれているんですね。我々が観測しているアステ望遠鏡などではそのような塵やガスというものを超えてサブミラーという波長で見ていますので、今回のような発見をすることが、できたと考えています。
The young Japanese scientist had brilliantly captured an ancient monster long hidden in deep space. It might just be the largest galaxy in the entire universe. This discovery attracted worldwide attention and prompted an international project to pursue it further. One project member is astrophysicist Julie Wardlow of the University of Copenhagen.
Oroτσι was so bright, it was almost unfathomable. We couldn't figure out what made it so bright, so it was interesting just from that point of view.
This is the image from Wardlow's observation. The reddish blob is Oroτσι. Wardlow noticed a small galaxy 3 billion light-years closer than Oroτσι. Was it playing a role in what we see?
So this white blob is the foreground galaxy that is gravitationally lensing and magnifying the flux from Oroτσι. And that's why we see it so bright in this image.
Gravitational lensing refers to the way the gravity of gigantic masses warps the space around them. It bends light and radio waves, affecting them like a lens. So gravitational lensing makes the Oroτσι monster appear even more gigantic than it is. In defining Oroči's shape as well. The lines indicate the temperature distribution of various gases. Computer enhancement yields an image of a turbulent galaxy. Oroτσι is thought to be not a spiral like the Milky Way, but rather a lumpish, irregular shape. Enveloped in a cloud of thick gas and dust is a tight concentration of 5 trillion stars. With such an abundance of gas and dust, the building blocks of stars, Oroτσι is birthing stars internally at a fantastic rate. Their radiation heats up the entire galaxy, producing intense radio emissions. The universe came into existence 13.8 billion years ago. And now, astronomers searching 10 billion years or more back into the early history of the universe are finding other monster galaxies like Oroτσι. For some reason, they are concentrated only at the universe's very beginnings. Why did these monster galaxies exist in the ancient universe? Astronomers are facing a monster mystery. A clue to solving the Oroτσι mystery can be found in an investigation carried out 30 years ago. In 1983, IRIS was launched, the world's first space-based infrared observatory. Infrared wavelengths from outer space are difficult to detect on Earth, obstructed as they are by the atmosphere. How would space look in infrared? That's why astronomers were keen to launch the space-based IRIS. This is an infrared image captured by IRIS. Several objects were discovered which were emitting more intense infrared radiation than anyone had imagined. It meant that these objects were violently active. When the sources of these infrared emissions were investigated, they were found to be strangely shaped galaxies. They were of a type called, technically, peculiar galaxies. There are three main types of galaxies. The best known type, accounting for 77% of the total, is the spiral galaxy. Our own Milky Way is a spiral galaxy. The next most common, some 20% of the total, is the elliptical galaxy, orange-colored with no swirl. The remaining 3% come in all sorts of shapes and sizes, the so-called peculiar galaxies. The peculiar galaxies had a secret, a common trait, revealed in images taken by the Hubble Space Telescope. Consider these images. Each of the peculiar galaxies shown here represents the amalgamation of two giant galaxies. Any such merging of galaxies is a momentous event in space. Astronomer Chris Mijos studies the collision of galaxies using computer simulations.
When we look out using the Hubble Space Telescope, we see many examples of colliding galaxies. But since a collision takes many billions of years to happen, we can't watch a real galaxy collide over the whole course of the collision. And so by taking the simulation and saying what galaxies that we see with Hubble look like what part of the simulation, we can take those snapshots in time from Hubble and understand where those galaxies live on this long evolution of a collision. So we start the simulation with two spiral galaxies, two disk galaxies. So what you see here are one galaxy is like this and the other galaxy is like this. So they are tipped relative to one another.
Attracted by each other's gravitational forces, the two galaxies approach each other. Here is a Hubble image of two such galaxies in the moment before they collide. In the simulation, a likely collision is initiated. But the stars themselves don't collide. They remain several light years apart. This image shows one of the peculiar galaxies halfway through the collision process. Once galaxies collide, they usually separate. Stars and gases stream away from each of the galaxies. Their long tails streaming behind them, the galaxies collide again. Over the course of hundreds of millions or billions of years, the two galaxies will gradually merge. These momentous collisions yield a whole range of peculiar galaxies.
I think one of the things that we're learning through the simulations is exactly how the gas clouds in a galaxy respond when two galaxies collide. As we look out in the universe, we see many examples of galaxies in collision, and they are forming stars often at a very high rate, but not always.
Haverford College is in the state of Pennsylvania in the U.S. There, astrophysicist Deshika Narayanan studies the stars produced by galactic collisions. This is a simulation isolating what happens to gases within galaxies when there is a collision. Gases are widely dispersed, but over time are drawn back towards each other. After about 1 billion years, the gases from the two galaxies have been drawn into the central area, where they become tens of thousands of times denser.
So when a galaxy merges with another galaxy, typically most of the gas is driven into the very central regions. So under normal circumstances, the gas will be quite distributed in a galaxy and spread out over much of the extent of the galaxy. But when they bang together, the gas is driven into the central regions. And when you have very, very high gas densities like that, when you have a lot of gas in one small confined area, you tend to form a lot of stars at once.
Stars are formed from concentrations of gas and dust. When galaxies collide, there is abundant gas at the center. Giant stars can form rapidly. This phenomenon is called a starburst because of its explosive quality. The antennae galaxies are clearly in the process of colliding and merging. Violent starbursts are visible. The reddish areas are where the gas and dust are densest, and where stars are born. The bright bluish areas show the abundance of newborn stars. Most of the peculiar galaxies detected by IRIS due to their intense infrared radiation emissions have also featured starbursts. The Oroτσι monster galaxy grew huge in just that way, by producing stars in violent starbursts. Yoshiaki Taniguchi of Ehime University was among the first in Japan to study these monster galaxies. He had doubts whether monsters like Oroτσι, which contain an enormous number of stars, could be produced by just two galaxies colliding.
最初にそのモンスター銀河を合体で作りましょうっていう論文を読むと2つの銀河の合体って明確に書いてあるんですね。で、僕も普通銀河の合体っていうと2個の銀河が合体するってこれ一般的に誰しも思うことなんでそういうもんなんだろうと僕も最初はそう思ってたんです。
But what if a collision between just two galaxies is insufficient to produce a violent starburst? It occurred to Taniguchi that there might be such a thing as a multiple merger. Multiple galaxies would collide. In 2012, Taniguchi encountered a strange new monster. ARP 220 is one of the monster galaxies detected by the IRIS space telescope. It has about 10 times as many stars as the Milky Way. Taniguchi outfitted the Subaru telescope with a special filter for his observation of ARP 220. That revealed an irregular dark band extending above and below the galaxy. It indicates the tails formed during a galactic collision. The tails contained numerous young stars produced during a starburst. Starbursts are triggered by dense concentrations of gas. Ordinarily, young stars produced by starbursts do not exist in galaxy tails. So why is there evidence of starbursts in the tails of ARP 220? The answer was a multiple merger. When galaxies collide, starbursts occur. Elsewhere, other galaxies can collide, also producing starbursts. When the two new systems themselves collide, even more intense starbursts are induced, with newly born stars occurring even in the tails.
近傍の宇宙見てみると銀河の群れ、銀河群っていうのは随分あるんですね。昔あったそういう銀河群が一挙に合体してしまってモンスター銀河になってもいいんじゃないかなと。つまり二重合体ではなくて多重合体の方がいいんじゃないかと。
This is a simulation of 5 galaxies in close proximity to each other, an area of space 800,000 light years across. After a billion years, 3 of the galaxies merge. Then the others merge as well. Eventually, the 5 galaxies become one monster galaxy. But did this sort of multiple merger actually happen in space? Astrophysicists Mark Vogelsberger and Anna Pilipich study how galaxies evolve.
So we could do something similar and then also make a more detailed analysis of these.
The two scientists have collaborated in a computer simulation of the universe's evolution from its origins to the present day. It is thought that the universe originated some 13.8 billion years ago in a huge explosion called the Big Bang. Right after its birth, the universe was a place of seething gases, hydrogen and helium. Hundreds of millions of years later, numerous stars formed in areas where the gases had gathered. Eventually, they became galaxies. These early galaxies were small, several thousand light years across. Where the galaxies had accumulated most densely, they began to collide.
So this is a single galaxy, which is a disk galaxy, and then you see some smaller galaxies merging with this galaxy. And also in the background you see plenty of other galaxies actually. So this is a whole region where there are a lot of galaxies. And as the movie progresses, you will also see that there's an interaction of multiple galaxies. So this comes in a second. So you see we fly here through the universe, and now there are these groups of galaxies like here, and they will now all interact and merge and then transform and produce new galaxies essentially.
The early universe was far smaller than it is today. In such an environment, it was relatively easy for galaxies to collide.
So it starts from small structure at very early times, lots of small galaxies, a couple of billion years ago, and then these small galaxies, they merge together and build bigger and bigger galaxies. Like the Milky Way is also assembled out of lots of small galaxies, so which are accreted and then merging with the galaxy. And the process of star formation combined with the process of merging leads to a net growth of mass of all the galaxies and also of the size, which explains why the biggest galaxies are observed today.
Hundreds of millions of years after the birth of the universe, masses of galaxies overlap and interact, yielding multiple mergers again and again. The simulation shows a monster galaxy like Oroτσι developing in just such a way. Peter Kapak is a research scientist at the California Institute of Technology. He's a member of the Cosmos Project, devoted to the earliest period of the universe. The Cosmos Project compiled 600 images taken by the Hubble Space Telescope to create a composite picture of the ancient universe. Those bright spots that look like stars are in fact distant galaxies, each and every one. Altogether, over 1 million of them. In December 2013, Kapak discovered amongst them a monster galaxy.
So this is the most distant monster galaxy we found so far.
This is that monster galaxy, 12.5 billion light-years away. That means it existed 700 million years prior to Oroτσι.
We found these monster galaxies right at the dawn of time, when the universe was only about 1 billion years old, that were already forming stars at a rate of a few thousand a year. And how did we actually build these things up so quickly? It's imagine you found a giant city like New York 2,000 years ago. How did that happen when the universe was so young and you didn't have time to build up all the material needed to build those up?
As observations became more accurate, more monster galaxies were being discovered farther away. These monsters have turned up in the era immediately following the Big Bang. The dawn of the universe. It was the age of the great galaxies, when giant monsters reigned. November 2013. The homepage for the Hubble Space Telescope announced a supergiant space object. The same article appeared on the website for the U.S. National Radio Astronomy Observatory. It was also featured by NASA's Jet Propulsion Laboratory. The name of this entity, Hίμικο. Hίμikō, the fabled queen of ancient Japan, now a cosmological mystery. High atop Mauna Kea in Hawaii stands the Subaru telescope. It was here that a telescope operated by Japan provided the first ever sightings of Hίμikō. The discovery was made by Masami Ouchi of the University of Tokyo. In 2007, Ouchi was using Subaru to scan for galaxies at the beginnings of the universe. This is an image from that observation. In the midst of a multiplicity of galaxies lies a tiny red blob. That's Hίμikō. Dating to just 800 million years after the Big Bang, this is an ancient body, 13 billion light-years away. Further observation revealed that its diameter was 55,000 light-years across. Compared to a typical galaxy of that era, the mystery object was about 10 times as large. This was a mega monster.
こんなに大きいんだからこれは近くの銀河で何らかのその誤差とかエラーで遠くの銀河だと思ってそのサンプルに入れてしまったものだというふうに最初は思っていました。
Since the size made it so far out of line with expectations, Oroτσι initially excluded it from his observational findings as an error. He recalculated the distance to the faraway galaxies he'd found with Subaru, this time using one of the Keck telescopes. On a whim, he included the suspect galaxy he'd initially excluded. But the result was the same measurement of distance, 13 billion light years.
これはすごいというふうに思って、うわーというちょっと叫び声みたいなものをちょっと上げてしまいました。
It was Oroτσι who gave this gigantic heavenly body the name Hίμikο. Astronomers worldwide then devoted themselves to solving the mystery of what Hίμikο was. Pisa, Italy. The town of Galileo's legendary experiments with gravity. At the Scuola Normale Superiore in Pisa, Andrea Ferrara uses computer simulations to study Hίμiko's attributes.
Questa è il confronto tra Hίμikο fatta al nostro computer, prodotta dal nostro supercomputer, confrontata con Hίμikο stessa. Come vedete, con le simulazioni riusciamo non soltanto a far riprodurre più o meno quello che noi osserviamo, ma anche ad avere un dettaglio molto maggiore.
To the right is Hίμikο, as derived from the image and data provided by the Subaru telescope. The blue regions are gases. Red indicates high-energy areas. As we watch this rendering of internal structure, we see a number of yellow and red high-energy areas. Ferrara hypothesizes that Hίμiko's internal profile suggests a concentration of active galaxies.
Come dicevo prima, Hίμikο è una galassia estremamente, è stato addirittura più di quanto potevamo aspettarci, perché è una galassia veramente stupefacente, bellissima, molto particolare. Non ci aspettavamo di trovare un gigante così, è stata una scoperta molto fortunata e allo stesso tempo molto importante.
To identify Hίμiko's attributes properly, clearer images were necessary. September 2010. The Hubble Space Telescope turns its gaze on Hίμikο. The following month, that data is sent to the University of Tokyo. Oroτσι immediately begins studying the newly observed images of Hίμikο. This is the moment of that first encounter. In the unfiltered, noise-cluttered, raw image before him, Hίμikο presents as a stretched-out cluster. The blue gas blob seen by Subaru concealed within it a long, thin galactic structure.
思った以上に細長い
天体になってこれは予想してなかったことですし、これはどうしてなのかなっていうのは今後ちょっと詳しく調べていきたいと思っています。
The observation with Hubble took 20 hours. Assembling the data and filtering out unwanted noise took a whole year. Finally, a true picture of Hίμικο began to emerge. The long, thin object in that initial image resolved itself into a row of 3 very bright galaxies. The 3 galaxies are enveloped in gas, probably hydrogen. Triplet galaxies, a most unusual structure in space.
3つの銀河がですね、合体する現場を見てるかもしれないというふうにも思えるんですけども、ただ一直線に並ぶっていう確率は非常に低いんですよね。であとそもそもですね、3つの天体が同時に合体するっていうような現象はさらに稀な現象だというふうに思えてですね、それは非常に面白いというふうに思いました。
Hίμiko's true shape, revealed at last by precise observation. Distance from Earth, 13 billion light years. In the midst of a gas cloud 55,000 light years across, 3 galaxies are found all in a row. Each one of them far larger than other galaxies of a similar age. It is even possible that by a multiple merger, the 3 galaxies could combine into one giant galaxy. Hίμικο could represent the birth of the universe's most ancient monster galaxy. In 2012, the ALMA telescope focused on Hίμικο in its longest ever observation. Oroτσι focused on radiation emitted by carbon dust and other substances. The composition of the dust should provide indications, he thought, as to Hίμικo's evolution. In February of 2013, the data arrived, but the results were unexpected.
データを見て、正直がっかりしました。最新鋭の望遠鏡で、これまでで最も時間をかけたくらいのその観測を行ったにもかかわらず、何もシグナルが見えなかったという点で、最初は非常にがっかりしました。
This is an image taken by ALMA. That visual signal noise doesn't let us see much of anything.
この左上の方にはですね、何か白い塊があります。で仮にですね、Hίμικoからですね強い電波が出てればですね、ここにあるようなですね白い塊のように見えるはずであると。これだけあるまで、感度の高い観測をして、それでもなお、見つからないということは、逆にこれはすごいことなんじゃないかというふうに思えてきまして、いろいろ解析を進めることになりました。
Hίμικo had no detectable dust. This itself was an astounding discovery. The reason there is no dust can be traced back to the beginnings of the universe. At first, space was filled with hydrogen and helium gas. There was no dust. After several 100 million years, the first stars were born. They were made entirely of gas. They had short lifespans. After only a few million years, they exploded. The massive explosions of these first stars scatter heavier elements, such as carbon and nitrogen. This was the first dust in the universe. Thus, the stars and galaxies forming after the first stars should all have dust present. But no dust was detected in Hίμικο. That riddle was taken up by astronomy websites all over the world. This is Richard Ellis of the California Institute of Technology, who researches Hίμικο together with Oroτσι. He has a theory as to why no dust has been observed in Hίμικο.
I imagine that we were witnessing a young galaxy forming for the very first time. Most galaxies that are forming stars at this very high rate glow in a carbon line. Now, the ALMA telescope in South America is very, very powerful. And we've confidently predicted that we would see this carbon line. And to our surprise, we didn't see it at all. And this could very well indicate that the galaxy is genuinely very, very young.
In other words, if further observations find no dust present, it could mean that Hίμικο is a galaxy comprised entirely of first stars. And if that is true, then scientists are looking at a new cosmological scenario in which a giant galaxy had formed at the very beginning of the universe. With ALMA fully operational, scientists decided to undertake an even more lengthy observation. When Hίμικо's true form was finally revealed, a new page would be written in the annals of cosmology. A monster galaxy, born at the dawn of the universe. It's not just the size of these monsters that's being established. The facts surrounding their dramatic end are also becoming clearer. Johns Hopkins University in Maryland. Here, there's a scientist who studies the life cycles of monster galaxies, Tim Heckman. He says compared to the lifespan of the universe, the lifespan of monster galaxies is extremely short. Galaxy M82. From its midsection spurts a giant plume of red gas in two directions. Heckman calls this phenomenon a superwind. It's a galactic wind that spews out enormous volumes of gas and dust.
When stars that are more massive than about 10 times the mass of our sun end their lives, they end their life in a very powerful explosion called a supernova. When all these massive stars end their life, and they live a very short life compared to the sun, these explosions then can drive this powerful outflow.
When infrared emissions are viewed, the intensity of these winds is noticeable. A superwind instantaneously changes the destiny of a monster galaxy. Giant stars born from starbursts have a brief lifespan of a few million years. Stars born together mature together, and at the end of their lifespan explode together, one after another. With the shock of these explosions, the gas and dust expand into a huge bubble. Eventually, the bubble bursts, causing a superwind. The gas and dust are flung a tremendous distance. This means the end of the era of the monster galaxies.
We think that the superwind may play an important role in blowing all the gas out of the galaxy so that the galaxy afterwards effectively is dead at that point. All the cold gas that it could use to form new stars has been ejected. The disk of the galaxy no longer exists, and we have this big round galaxy. Now, we know that elliptical galaxies throughout the universe are essentially dead objects. They're not really forming stars at a significant rate anymore.
An elliptical galaxy has many aged stars. There is hardly any gas or dust that can produce new stars. Some elliptical galaxies are considered to be the form into which monster galaxies devolve after the advent of superwinds. Superwinds are thought to play a great role in the evolution of the universe. The superwinds spread heavy elements essential to life, such as carbon and nitrogen, throughout the universe. As components of the stars and planets, these heavy elements promote the growth of other galaxies.
A galaxy, of course, is producing stars. Those stars are nuclear reactors that convert hydrogen into helium, helium into carbon, carbon into magnesium and iron. So all the material that makes up you and me is produced in these stars. These stars then explode as supernovae. When we look at stars and galaxies today, they have the heavy elements. So this process of winds from supernovae polluting the gas in space is a very important part of the evolution of the universe.
At one time, our universe was ruled by monster galaxies formed by multiple galactic mergers. With those huge explosions, the giant monsters lost their luster. The momentary brilliance of their supernovae spread the ingredients for life throughout the universe. That eventually enabled the existence of human beings. And now, in closing, some special research. Giant galactic collisions are not simply a matter of history, but will be a part of the future of our own Milky Way galaxy. The Andromeda Galaxy lies 2.3 million light-years away from the Milky Way. The two galaxies are rapidly approaching one another. Roland van der Marel of the Space Telescope Science Institute. Precise observations of the Andromeda Galaxy have led him to predict a collision.
So this is a computer simulation that we did, that I will start and show. This is our Milky Way galaxy, and our sun is somewhere here, and we go around in circles. And when I start the simulation, what you will see is that our Milky Way galaxy, it rotates.
Let's find out how that collision will occur. Andromeda comes into view, 2.3 million light-years away. The two galaxies are approaching each other at 400,000 kilometers an hour. The collision will occur in 4 billion years. After a head-on collision, the two galaxies will separate once, then merge. 3 billion years after the collision, it will have been transformed into a single galaxy. Astronomers have already given this new galaxy a name, Milkomeda. The name Milkomeda is itself a merger of the names Milky Way and Andromeda.
So the Andromeda Galaxy and the Milky Way Galaxy will collide about 4 billion years from now. And probably humans will not live on Earth anymore at that time because the Earth will be too hot. However, it's very well possible that some civilization may still be around. And if so, they would be able to witness this event.
A time-lapse look at the night sky in 4 billion years. The once far-off Andromeda Galaxy is steadily approaching ours. Andromeda and the Milky Way collide and disintegrate. The gas and dust from each galaxy blend together and thicken. A starburst occurs, producing many thousands of stars. The newborn blue stars will shine all over the sky. These starbursts will continue for about 10 million years. In 7 billion years, the Milky Way and Andromeda will have merged completely. In its stead, the round core of a new galaxy will be shining bright. Monsters of the ancient universe. By discovering the true attributes of these monsters, astronomers have also come to an understanding of the awe-inspiring evolution of our universe, with implications for the future of human life in the cosmos.